Hello everyone, this is the second video, activity 3.4, dead zones part 2, and during this presentation video we will be focusing on how to complete the explanation tool. Our explanation tool looks like this. This is for parents, and I'm going to explain each section that we have here and how to complete them. So this is your guide on page 84 on your handouts, and we will be following this guideline. So we will first start with question, evidence, then we will look for some science concepts, scientific reasoning, and claim. I recommend you to first write down your question, which is always provided, and then go ahead and complete your claim. I believe that works better. So parts of the explanation tool, just like we saw on the previous slide, we have a scientific question, and then we make our claim. After that, evidence, we look for science concepts, and then finally we finish explanation tool by completing the scientific reasoning part. So for this particular explanation tool, the question that I gave you was, what is the effect of water flow from the Mississippi Basin on the total nitrogen input in the Gulf of Mexico? So I believe this is the most important part, understanding the question, because you have to stick with the question. What I saw in the classroom today was some students are talking about dead zones, how nitrogen input increases, decreases the size of dead zones. That is right, nitrogen changes the size of dead zones, but this question is not asking how it would change the size of dead zones. What we must focus on is that I highlighted the effect of water flow on the total nitrogen input. So this is the question part, and what you need to do simply is copy down this question on your explanation tool. That's all for the question part. That's the easiest part, but also it's really important understanding the question. So evidence, the guide that I showed you and you guys have on page 84, it says examine the data in the graph and information from the introduction. What pattern do you notice in the nitrogen input and water flow data? Describe these patterns. Include data with units as evidence from the graph to support your description. So if you look at your handouts, you'll see that we have only one graph that gives us information about nitrogen input and water flow. This is also the same graph that we worked on the previous video. So this is the only graph. This is where we are going to collect our data, collect our evidence for the explanation tool. So here's the graph again, and the question was, what's the effect of water flow on the nitrogen input? Let's take a look at the same time period as we did yesterday. So between 1981 to 1983, So, as we discussed yesterday, from 1981 to 1983, water flow increases. And between, let's see, 2010 to 2012, water flow decreases. So this was the pattern that we see. You can write this down as your evidence. You can say, as water flow increases, total amount of nitrogen is also increasing. And same here, as water flow decreases, nitrogen input also decreases. So the guideline says you can also put some data with units. So let's take a look at how you can do it. Okay, same time period we will be looking at between 1981 to 1983. So water flow is the y-axis on the right side. So in 1981, let's see how much water did flow. So let's say 14,000 meter cube per second. And in 1983, it's like 29 maybe. It doesn't really matter, but the water flow increases. Also during the same time period, in 1981, we have this much nitrogen, and then 82, and then 83. So from this point, let's say 1300 maybe to 2200. So from this point, 1300 to 2200, nitrogen input also increases. So they are parallel. Water flow increases, nitrogen input also increases. So this is the pattern. As water flow increases, nitrogen input increases as well. Also, as water flow decreases, nitrogen input decreases too. From 1981 to 1983, water flow increases approximately 1500 meter cube per second. This is the part that the guideline, it was asking for us to put some data with units. So also from 1981 to 1983, nitrogen input increases. Okay, increase and increase, approximately 900,000 of metric tons per year. So that's the evidence. So what are science concepts? This is the part I guess we are struggling the most. A science concept is an idea or model explaining some natural phenomenon. So I gave you an example um, of gravity. So I ask you, think about gravity, and when I say gravity, you don't just think of an object. So you think about a process. So when I say gravity, it is something that you need to visualize in your mind. So when I say gravity, I start thinking about Earth and then an object falling towards the Earth. So, and I need I need an arrow to show that it is falling downward. So this is a really simple way to represent or visualize gravity. So it is usually a concept. It's usually an idea or model explaining some natural phenomenon. I'm going to attach some link in the description. So if you would like to learn more about science concepts, I believe that that would be really helpful if you just take a look at it. And for this specific explanation tool, our science concepts are dead zones and fertilizer runoff. Dead zones and fertilizer runoff. Scientific reasoning is the part that you answer the question why your claim is right. How can you make someone believe that your claim is right? How can you convince someone whatever you're claiming is right? So describe the scientific reasoning that connects the evidence and science concepts to the question you are trying to answer. And for this explanation tool, we can say something like, if there is more water falling on more farms, that will cause more nitrogen to be washed from basin into the Gulf. So this explains why as water flow increases, nitrogen input increases too. Claim based on the guidance that we have, guideline that we have, it's the last thing that you need to do. That's why the explanation says, based on the evidence of patterns in the data and on your scientific reasoning, state your claim about the effect of water flow from the Mississippi Basin on total nitrogen input in the Gulf of Mexico. But I recommend you to first make a claim and then look for evidence, science concepts, and scientific reasoning. For this question, our claim would be an increase in water flow in the Mississippi Basin will lead to an increase in nitrogen flowing into the Gulf of Mexico. So as water flow increases, total nitrogen input increases, or you can also say as water flow decreases, nitrogen input decreases too. So this completes the first page of our explanation tool. You have all the pieces, you have 5 pieces to put a paragraph together on the back side of the explanation tool. And the paragraph may sound like this. So the first part is our, oops, wrong color. Okay. The first part is our question, and that's the question that you need to just simply copy it down. So what is the effect of water flow from the Mississippi Basin on the total nitrogen input in the Gulf of Mexico? And this is the complete paragraph. An increase in water flow in the Mississippi Basin will lead to an increase in nitrogen flowing into the Gulf of Mexico. Data shows that in most years, when there is increased water flow in the basin, there is higher nitrogen input in the Gulf. There are many farms surrounding the rivers and streams in the basin, and excess fertilizer used on those farms can be washed into the waterways, causing an increase in nitrogen. An increase in water flow will cause an increase in nitrogen input because it is washing away more fertilizer. We usually go like, my question is that what is the effect of water flow from Mississippi Basin on the total nitrogen input? And then we say my claim is, and you talk about your claim, and then my evidence, my science concepts, and we finish with scientific reasoning. So this is how you needed to complete your explanation tool. If you decide to do it again, redo, you can use this video as a guidance to complete your or improve your explanation tool. So I hope it helps, and see you on the next one.